Hello. Today we are going to continue our class regarding how to create a point library of a T-shaped pier. Okay, so the purpose of our classes today is to create a pier which also includes rebar, 钢筋, also include transfer from CIM to the Midas Civil. So we will be doing some interaction within the two applications that we have, the CIM and the Midas Civil. Okay, so the first chapter of our creation of point library is to create the point library settings, and then we will do the modeling of the top part. So the top part will be the coping, and then we will do the column modeling, and also we will do the foundation modeling. The foundation modeling will include the bottom part. So the bottom part will be like a thin slice of concrete. So it will be called lean concrete. Okay, so the first part is that we just have to choose the point and create. So we will create a point library here. We can just change the name to pier and then apply and close. And then we would like to create a user section in the base here. We can create the user section. We can click create, and we can name our first user section COP1. So it will be coping 1. Okay, and the material type will be concrete, and section type will be general section. Okay, so after that, assuming that we have DWG, so the files from AutoCAD, we can import them from clicking the logo here and clicking import and clicking DWG or DXF. So this is the file that we have been downloading from the website cim.refine.site. So we can click on the DWG folder here, and we can click on the coping. So this is the DWG section of coping. We can click open. Okay, and then after that, we would like to assign the plate, the two dimension that the section will be inserted. So we want to insert the section in this plane. So after you click the user section, you can just click here in the middle to create the X direction and click the Y direction for the second one. So you can see in here, this is the default. This is the 3 points default in the defined location. You can see that the X and Y is the one that can be edited, but the Z direction cannot be edited because we only choose the X and Y direction. And then to ensure that we get them correct, you can just click preview, and you can see here this, and then just click OK. Then after that, we have got only lines here, as you can see, but there is no area in here. So what we are going to do is just click section in the shape ribbon here. You can click section, and then you can click by select, because you already have the line here. You can just drag and select all of them and click add here. So you can see here you have a phase 1, and then you can just click OK. Okay, after that you can just click here to finish the drawing of the user section, and then you can click on model, and you can click model to see all of the option, but in this case you can click base, and then you want to click on the model, and you can click on general, and then you can click create. You can see that in here this is the list of section that you have been creating, sorry. And then you can click on the user section here, concrete, and then COP1 here, and then you can click on by 3-point, and because you want to make the section in the vertical direction, so you want to click S so that you can see here the point is moving on the Z direction. You can click on here the X and Y direction. You can click assign. You can see that the coping is already there, and then you can change the number to 1.35. You can click assign so that the extrusion can be created. As you can see here, the middle is inside the section, so the purpose here is to have the middle of this part inside the area of the coping here. And then you want to click on direction positive and change the length to 2.7 meter. You can click preview here so that you can see that the middle part is inside the area of the coping. You can click apply. Then after that we want to create a concrete column in this part. So the way to do it is just click on concrete and click on column here, and then we want to click on the property. You want to click on this part and change the section type to solid round with a diameter of 2.5 meter. Okay, and you want to click on the create tab again, and then change the column height to minus 17.2. Why minus? Because we want to create the column going downward. Okay, and then we want to click on here in terms of the point, and until the cursor here is having a blue background. As you can see, the column can be assigned easily, and then you can click on the snap here and then just click. So you can just click on the middle bottom part of the coping here, click, and then check mark. Okay, after that we want to create the foundation, but previously we have been creating the column from wizard here, and this time we want to create the foundation from importing the DWG. So what we are going to do is click on base and click on user section to create, and then just change the name to foundation. Click OK. and then we want to click on CIM and import as usual, foundation, and then we want to click on this part. So this is just to determine the direction, so you can just click preview, similar to last one on coping, and OK. And also similar, to create a section, we can just click on section. You can click by select and choose here and click add, and then OK. So as you can see, we are having two user section here, COP, this part, because we imported them from DWG, and foundation because we also imported them from DWG. But we don't have the column here because the column is not imported, but we have them in the structural member here because in this case we have already converting the imported coping to the beam side here, but the column here is not being converted because we only created them from wizard. Okay, so after that, because we already have the foundation here, we can just click on general and create, and we can choose the foundation here and click on the by 3-point. So because we want to create the 3-point in this part, so we can just click F, so it will be creating the front plane, and we can just click here, here, and here. You can see that the user section is heading on the right side, and we can just change the origin to 0 minus 3.5 and minus 19.7. So this will be in here, as you can see, and then we can extrude them similar to last one, and we can change the direction to negative -7. You can assign first, and then you can change the length to -7. So the term minus here is minus absolute to the direction. So if it's -7, so that the direction will be negative and the length will be absolute. So the length will be 7. And then apply. And then it's also similar. We want to create another user section. We want to create a lean concrete, but the name is only just lean. And then we want to create after you create a user section, you can just click OK, and then similar to last one, we want to click here and import NDWG, and this is the lane. Again, we want just to click open. Okay, and then just simply click on this side, and this side, preview, and then just apply. Similar, you can just click section by select and select the line and add, then just OK. So you can see you have COP, foundation, and lean. After we done creating the lean concrete for the user section, we want to assign the lean concrete here. So what we are going to do is just click on general and click create, and then we can change the user section to lean, and then with the option of by 3 points of assigning the user section, you can click on by 3 point and click in the middle part X direction and Y direction. Okay, and you can change the number to 0, minus 3.6, and minus 22.2. You can click assign. As you can see, the section is in this part aligned with the foundation. And then, as you can see here, because the direction is in the positive for the X direction and positive for the Y direction, it means that if you click on positive here, the length will be generated on the right hand side here. Let me show you. So if it's 7.2, if you click preview, the generation will be in the right hand side. But if you click on the user section by 3 point, first point is in here, second point is in the X direction, but the third point is in the minus Y direction here, the orientation of this part will be different. So if you click on positive in this absolute number, the number will be in backward, so it's in the left hand side. So it is also it is important the way to click the sequences. So click the first part, the second part, and third part. So this is important. So if you want to fill the lean concrete in this part, you can just click on negative and click preview. Okay, so after that we want to create a constraint point. So this constraint point is like a reference point. So this will be important if you want to uh, pinpoint your model here, pinpoint them to the standard. Okay. So the way to do it is just click on the point library here. Okay. And then just click on the constraint entity in here. You can click on the ribbon constraint entity in the button point here. And then you can just make sure that the location is 0.0.0 here, and then click OK. You can see that there's a button here. Okay. As you can see that the button is not in this direction, so this is wrong. So you can change them to 0 and then OK. And you can see that the constraint entity is at the top of the column. And then you can, after you click the constraint entity of point, you can click on the expression entity of single point, and you can select all the target. So in the first option you can select all the target, and then you can change, you can click on the constraint point, and you can click on the constraint point that previously created. Okay. And then after that you can just export the library. So the way to do it is two-way. The first way is to click on export, and then if you want to uh, export them by this way, you can just change the name to maybe export underscore peer, or the other way around is just to click on apply, and then in this case in the work tree you can see the point library here. You can just right click and export. So this is similar. Okay, so the next part will be regarding how to create the rebar. It's okay. So in this case, we already have the point library here, and we want to see the inside of the model. So we want to make sure that you can see the rebar. So you want to click on view here, click on this button, and click on the concrete transparency, and then click on concrete member, and click mono, and then change the number to either 0.1 or 0.2. In this case it's 0.2. You can click OK, and then when you modify the point library, you can see that the point library has a transparency of 0.2. Okay, so we want to draw the rebar. You can see you can click on rebar and draw here, and then select target member. In this case we want to draw rebar for foundation, and then select plane. We want to click on this plane here because the reference path is in this direction, so we want to click on this plane here, and direction will be in this side. So as you can see, this is the area of rebar that we can create. The first part is the transverse rebars. We want to click on the property here, and we want to create the first transverse rebars of B1 with a diameter of T25, bending radius of 89, with a cover thickness of 100 millimeter. Start plane is also similar, with the offset of 125 and 125 here. Okay, and then for the hook, we want to create a hook of 90-degree custom hook with a radius of 89 with a length of 500 millimeter. Okay, so in this case we want to create in the straight bar with the edge of the top hand side here, then click blue part. And then for the bottom part, bottom transverse, we want to create P2 here with a cover thickness of similar, start plane of similar, offset of 100 millimeter here. And with the length of 2211, because we want to wrap the rebar from the bottom here, because as you can see the hook in here is only 500 millimeter, and the hook length of the bottom will be 2211. So in this case it will be wrapping the top bar. Okay, and simply just click on select edge and click on the bottom part here, click the blue part. Okay, now we want to create the longitudinal rebar. So we can click on longitudinal rebar here and click property, change the name to P3. Okay, with the diameter of T25, with offset of 127.1, similar to the end, with no start spacing. And for the hook, we want to make sure that the hook is in a similar fashion in the side, in the start hook and the end hook. So in the start hook and the end hook at the end of the longitudinal foundation here. So it means that we untick this one, perpendicular custom hook with plus 90 degree, radius of 89, with the length of 500 millimeter for the hook. Because this is longitudinal rebar, that means that we want to click on the arrangement here and change the arrangement to adjustable spacing of 200 millimeter. It means that adjustable spacing means that if the 200 millimeter starting from this side and doesn't end in this part of 200 millimeter, the spacing will be adjusted so that the average of all of the spacing will be give or take 200 millimeter. Okay, so this is for the top side longitudinal rebar. It means that we just click on select transverse rebars because the longitudinal rebar is connected to the transverse rebars. So we can click rebar here, select rebar, and select the top end side. In this case, the transverse rebars is outside the transverse rebars, which is not correct. So it means that we have to click on reverse direction so that the longitudinal rebars is inside the transverse rebars. You can click blue part. Now we are going to create the longitudinal rebar for the bottom part. Just similar in terms of the drawing, we click on the longitudinal rebar. On the property, we change the name to P4 with offset of 101.7, and the hook will be 90 degree with the length of 2173, with the arrangement of user defined of 101.64 at 100 millimeter and 101.111 millimeter. And then just similar, click on the bottom rebar here and click reverse direction and then blue part. And then for the sidebar in the left hand side here, we just want to create the name of P5. Okay, P5 with the diameter of T16, no offset, but the spacing starts from 200. In terms of the hook, we are going to minus 90 degree with a length of 47.7, radius of 47.7 with a length of 3540. So 2560. Okay, with the arrangement of pattern spacing of 300 millimeter. Okay, select transverse rebar, blue part. Similar to the sidebar in the right. We change this to P6, T16, with a spar spacing of 226.9, with a hook in minus 90 degree 47.7, with a length of similar fashion 3560, with a pattern spacing of 300 millimeter. You can just draw in this side and click blue. Okay. After that, we would like to array this rebar. The way to do it is just click on apply first, and then click rebar and array. And we would like to change, we would like to keep choosing the tapered array. Select rebar, we just select the rebar here, and then we can click the define end plane, select plane. The plane will be the opposite of the direction of the rebar. Okay, and then for arrangement property, we would like to change the adjust at first and last spacing, and then just apply and close. Voila. You can see that the rebar here is is copied at this direction. So yeah. So if you are facing with some kind of difficulty in terms of the array here, you can click on the particular array here. For example, the hook of P5. And after you click the point library here, the rebar here, you can see the second icon here. And then if, for example, the angle is peculiar, you can just change the angle, and it will be protruding on the to the outside. And if you want to change it back, you can just delete the minus here, and it will be come back to the inside. Okay, so we can move on to creating rebar at the column. Okay, so at the column, we will be to make it easier, you just click on the column and click the show only. Okay, and then click on the rebar, draw, select target member, select plane. So the plane will be on top, and the direction will be the bottom. And in this case, we will be choosing the independent longitudinal rebar. Okay, and for the property, we will be untagging the auto name of P1 with a rebar code of 3, T29, with cover thickness of 100 millimeter, with the offset. This one is interesting. So the offset will be minus 2200 millimeter. So this is for the start length. This will be the offset of the um, rebar. So in the real life, you may have noticed that in the column on the top side, there will be a protruding rebar. So and usually the rebar will be bent in the outside. So you will see at the results. Okay, for the 20, and for the hook, there will be hook and there will be a different hook because the start hook will be protruding on the outside to the outside like this, and the rebar at the bottom will not, at least will not as will be different from the start and the end point. Okay, so from for the start hook, as you can see here, different start and hook. You can see at the start point we will be having no hook, but at the end point we will have a custom hook with minus 90 degree with a radius of 270 with a length of 500 millimeter. Okay. And for the arrangement, it will be a number of rebars of 73. So this option here is just if you don't want to calculate the spacing of each rebars, because this is a circle area, so it will be much harder compared to a rectangular area. Okay, we move on to the drawing. So the drawing here, after you click the independent longitudinal rebar, you can click on the select line here. Okay, and then after that we can just click on this side and click on the other. Remember to click Control so that it will be selecting two instead of one, and click on, because I have clicked the line, click the inside of the line, it means that the rebar is already on the inside. That means you don't have to click on reverse direction. Click the blue bar. Okay. So moving on to the hoop rebar, so it will be the transverse rebars. You can click on transverse rebar and click on property. The property will be, because the first one is P1, it will be P2 with T19, bending radius of 67, cover thickness of 76, and the offset will be minus 370 for both parts. And the hook will be normal with a different end hook as well. The first one will be custom hook of minus 90 degree with a radius of 67, length of 150 millimeter. But the end point will be custom hook with the angle of 135 with the radius of 67 and the length of 150 millimeter as well. Okay. There will be no arrangement because this is a transverse rebar. Okay. So this is similar. Transverse rebars. You can just select line here. Okay. and you can just select the difference here is you you don't have to select both of them because the transverse bars on the left will be different to the transverse bars on the right. Okay, blue part, and then for the other one, it will be the other like this. With clicking the mirror hook. So as you can see, the hook is similar for the similar side. Okay, but in this case, we will be adhering with the tutorial. So it will be like this, and for this part, it will be 135 and 90. Okay. After this, we will be so after we have been creating the rebar here, you can just click OK here, and you want to show all of them first, and then you want to create a guide path. So this guide path will be important to create the reference line. So you want to create a sketch line here with a line of 2 points starting from line 2 points starting from the middle top to, so you can click F and you will be free to click on the vertical part. Okay, and this will be important to array this rebar. Okay, so the way to do it is simple. You just click on rebar and array, and click array along path because you already have a path here. It means that you can click array along path, and you can click the rebar here, and then you can click on the, because there is no plane here, um, because the plane is inside the concrete here. It means that the the plane will be the lean concrete in here. And then we click on select edge because we already have the reference part. The edge will be this sketch line. For the property, we want to adjust the spacing to user defined because we want to have a different spacing in each stages. 47 at 300 and 30 at 150 millimeter. Okay. Okay. As you can see, the start here has an offset, but with a straight line. So no angle differences between the main path and the offset. But the end part, it has angle here, as you can see, for the bottom part. So that's why the previous setting is important in terms of the offset for rebar. And then you can just delete the line here, sketch line. Okay, so we are going to move on to the rebar creation for the coping. So the coping is the top part here. So it's similar to the last one. You can just click on rebar, draw, and then select target member, and then select plane, and then select direction here. We'll instantly go to the cross-sectional view, and then you want to start by creating the transverse rebar with the name of C1 T22 with the cover thickness of 100 millimeter and offset of similar 122 and 122 for both start and end length, but with the similar start and end hook of 90° with a radius of 78 and length of 300 millimeter. Okay. Just so because this part is for top bar, so you can just easily select straight bar and select, because the end hook is already assigned, so you can just click on here and then just click the blue part. And then the second one for the bottom bar property, you can just click on C2 here, with D32 78 with the cover thickness of similar, offset similar, oh no, offset of 100 millimeter for both parts. And for the hook, there will be no hook. Okay, and to draw them, just use select line, because in the bottom they have a lot of edge, so it's not a straight edge. So you can click on select line here, and then starting from the side here, moving on, sorry, moving on with the control, click control here, 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 and here. Okay, just click apply and close. Okay, so the reason why we only create the transverse rebars but not the longitudinal rebar is because we will be creating the array of transverse rebars first, and then we will create the stirrups to fill the area inside of the transverse rebar. So we can just click rebar and array here, and then we will be clicking tapered array because the area here is tapered, so the side view is changing alongside of the area, as you can see. So we can just select the rebar here and then select plane. So remember, the plane will be the opposite of the rebar. So you can select here and you can change. You can click the rebar, the side view in this part, and you can just select edge. So the select edge will be the boundary. So the boundary will be in this part. Okay, and then you can just click property, change the pattern spacing to 100 millimeter. Okay. So for the array of the rebar, as I said before, there will be two transverse rebars to be arrayed, and then after that we will array once more the stirrups inside the area of the transverse rebars in the coping area here. So the first step is just to select the rebar. It's selected here, and then click select plane. It will be in the opposite direction of the rebar, and then click select edge. Okay, so the select edge will be at the edge of the rebar. Oh, sorry, the edge of the area, and then we click property, select pattern spacing of 100 millimeter, and then just click OK. So as you can see, the transverse is already arrayed at at this direction. The next step is to draw the other coping rebar, the stirrups. So it will be similar rebar and clicks, and okay. So in order to draw the stirrups, we will be drawing the stirrups from this side, but we also want to um, connect the stirrups to the existing transverse rebars here. So how do we do it? We just click on rebar here to draw the rebar, and similarly to the last one, we click on the select target member here, and in the define draw plane, we cannot use select define draw plane by plane, because if we select the define draw plane by plane, the stirrups will not be connected to the existing transverse rebars here. So the way to do it is click on curve normal, okay, and then we want to change the view range to 50 millimeter for both sides, and then we click pick point, and then just this one is the tricky one, so you have to be careful. We want to create the stirrups from this rebar here. So you should not click on this part. So you click on this part and then click the direction, and you can see the transverse rebars that have been created is seen in this side view. That way you can easily start your stirrups creation. Okay, so the way to do it is simple. You just click on shear reinforcement here, and then click on property to create your first stirrups. Name will be C3, so the coping tree. Okay, and T16 with the bending radius of 56, cover thickness of only 50 millimeter. Okay, and no offset with the custom hook of my angle of 135 with the length of 100 millimeter with the arrangement of pattern spacing of 1000 millimeter. Okay. Okay, onto the drawing. Um, in this case, we will be creating stirrups. Okay, stirrups from this side. Sorry, from this side, and it will have 6 rebar. 1, 2, 3, 4, 5, 6. Okay, so we just simply click Control and select this. So after you click Control, it means that the previous selected stirrups will be connected. And you can see there are two options here, close rebar and align bending center. Close rebar means that you want to close the rebar that you have been connected before. You can see after I click this, it is automatically connected. And you can see also there's a gap in here at the vertical part. There's a gap in here, and there's a gap in the bottom part and top part, and also in the corner. If you want to tighten your stirrups in your transverse rebars, you can just click on Align Bending Center. It means that the rebar will be at the exact corner of every um, stirrups, and you can just click Apply. Okay. And to draw the next rebar, you can just click on different property, change the name to C4, and change the cover thickness to 200 millimeter for both sides. Okay, and all of them are similar with you can just select you can just start to draw and click select, and it will be connecting the gap between the stirrups. So you can click on here, click control, and you can click on here. And keep in mind that you have to uh, keep the close rebar and align bending center turned on. You can click apply and close, and close. Okay, so the last one will be to array the stirrups that you have been created here, because you can see the rebar sorry, the stirrups here is only at one line, so you want to um, array them, and you cannot choose array along path. Why? Is because the cross section of the stirrups will be increasing. So it means that if you click on tapered array, the size of the stirrups will be similar along the way. And um, if you want to adjust the stirrups area in alongside the path, you have to click on tapered array. Okay, and after that you can choose the select rebar here. Okay, and then you can click select plane, and the select plane will be the opposite of the rebar here, and then you can select edge, and the edge will be in this part. And regarding the property, you can change the pattern spacing to 300 millimeter. Okay. As you can see that the stirrups here follows the cross-section area of each area of the section. Okay. So in this tutorial, we will be connecting the CIM application to Midas Civil. So the subchapter of the courses will be on how to define the drawing view. So for example, if this T shapes, you want to print the view, for example, from the cross-section part, from the top view, from side view, or maybe you want to see the only certain rebar. For example, you want to only see the stirrups in here but nothing else. You can do it using Midas cat ID, as you can see in the application after you you're done with the point library. As you can see here in the menu application, you can connect the CIM to Midas cat ID. This is the 2D creation application and the Midas Civil. Okay, so we will be moving on to creating a constraint point. Okay, so to do that, we will just modify the point library that we have been created earlier, and after that we will be clicking the point here, similar to the column side. You can just click at the 0, 0.0, 0, 0, 0, and 0, and then you can click on single point, and you can select target. It means all, and constraint point will be this part. And then we will be creating, as you can see here, there's a drawing view. There are two versions of this. The first one is the biplane. This will be a 2D layout. So you will only see maybe the front view or the top view or the bottom view, maybe the back view, the front view, and etc. In the Midas cat ID. So in this case, we will be creating the drawing view biplane. Okay. In this case, we will be having create a front view, for example, front view section, and then in order to do that, we can just click on define plane by 3 points. Okay, so um, for example, this one, you can click on the first point here, and if you want to see the view at the Z direction, so it means that you have to click F, so that as you can see, it's a front plane. So um, you may click on the S first, and then after that you can click on the F. You can see here. It means that the view is already in this three dimension, okay, and it depends on how many area that you want to see. So for example, you can just extend this to this, to this, and to this. So as you can see in this preview, the area seen is only in only the Y direction and Z direction, but the X direction should be extended as well, so that all of the area is seen in this box. Okay. And then you can see at the constraint point there's a select, and you can click select and select your constraint point, as you can see here. And to confirm that, you can see that the constraint point is already selected as seen there. You can click apply. And how to know if the drawing view is already there? You can see it in here, drawing view by plane. There are already a view in here, front view, that is active. Okay. And you can click on apply and close for the point library, and click on cat ID to run them. Okay, so as we have been creating the drawing view, you can just click cat and click run. This will connect you to the Midas cat ID, and as you can see, the open bracket, close bracket, there are connected sign in here. In this case, you will be redirected to Midas cat ID, and the top left hand side here, you can see that this is the CIM view. So this will list all of the initial view that you have created, and in the bottom left hand side here, this will specify all of the material, all of the rebar, all of the tendon that your view have. So for example, if your view has only concrete and only rebar, they will only have those two, and you can just tick or untick them to specify your needs. And in the top right hand corner here, you can see that this is the list of drawing. So CAD drawing in here. If you have a lot of CAD drawing, it will be listed in here. And in this one is the properties. If you want to change the font size, you want to change the line type, annotation style, and etc. So to see the drawing view, you can just double click in the front view here. It will generate the drawing. And in this case, if you want to see the object in this drawing view, you can just click on here, and it will have a concrete member and rebar. So you can all of the menu that is involved with the Midas cat ID with the Midas CIM is in this menu. You can just click here, and you can click on the annotation. This will create customized annotation for your rebar, but in this case you want to click on object show height, and you can click on the rebar annotation show or height in this case, or you can just click RAA. You can type RAA in the comment. Okay, if you click on this side, you can select, for example, this one, enter, and you can click show, as you can see here, S, enter, it will show you all of the rebar annotation that is inside this layout. So if you want to show all, if you're, for example, you have a lot of drawing view and you want to show all of them, all of the rebar annotation, you can just do so with click A at the previous comment, and you will show all of the rebar annotation. But if you only want to show rebar annotation for this view, when the comment says if you want to click A to select all, you can just select one of this layout. And to align the annotation, it's easy. You just click here and just align them as you wish. And if you happen to want to decrease the size of the rebar annotation, you can do so by clicking here and clicking the first thing first, you have to click the layout first, and then you can change the view scale. For example, if you want to decrease them in size, you can do so as well. And also you can change the style. As you can see, there are 5 styles in here. You can also customize the style of each style here by clicking Infra Design, click Style, and click Drawing Style Manager. You can see all of the style that the drawing view may have: dimension style, rebar annotation style, tendon annotation style, steel annotation style. And for example, if you want to create a rebar annotation style, you can just click here and it will guide you to the detailed customization of rebar annotation style. Okay. So what happens if you want to maybe add another view, but in that case you will only have a concrete? So you can just right click here and click copy. After you copy them, you can just right click and rename to general. It means that the front view in here, in this case, is this one. We'll have and don't worry, if you cannot click any grouping, you can just click on the rebar that you have. In this case, it's only front view general, but you don't have the rebar for the front view. You can just click on front view and it will automatically have them. Okay. In this case of front view, you can just untick the rebar and you will have no rebar whatsoever in this this drawing view. And if you want to maybe create a dimension, it's simple. You can just click on linear dimension and click first point, second point, and extension. And if you want to create a line, just first point, second point, dimension, extension. And if you want to create maybe a rebar dimension, you can just click linear dimension. You can specify your rebar, for example this one. So as you can see, this is the rebar. This is actually the stirrups. And after you click the stirrups, you can see that in here there are specified first extension, so it's similar to the linear dimension. Specify the first point in the concrete, click, and specify the second point, click, and then specify the extension, click. As you can see, this is the spacing from the left edge to the first stirrups, and this is spacing from the right edge to the right stirrups. and this is just the spacing of each spacing after the edge. What if you want to create another view, maybe a 3D view? You can just easily do that in the CIM. You can click on Peer and modify again, and you can click on the drawing view. There are 3D view here. You can click them, and in this case you can change the 3D view, the name to maybe ISO view. And be aware that if you have been clicking maybe drawing view or 3D view, and for some reason in this case the run cat ID is turned on, if you already have the cat ID open, you can just turn off this toggle. Okay, so if you turn on this toggle and you already have a cat ID open, you will overwhelm your system and may lead to crashing the app. Okay, so you may want to position your camera, position your view, and then click add and click apply. So as you can see, we have a front view and ISO view in here. You can just click apply and then click cat ID and click update. And then you can see in this case you can click also infra design and update view all. It will scan a new view if there's any. Okay, in this case you can see that the peer point library have an ISO view. You can double click, it will generate the ISO view. Okay, as I said before, if you don't have in the object only front view and front view general, but there's no ISO view to edit the rebar, just click on the rebar and it will automatically show you there are 3 grouping in here. And then you can just untick the rebar. Okay, and if you want to measure the dimension, just click infra design and click on 2.5 dimension. Maybe you want to click align dimension, and in this case for example, if you want to check on this part, you can do so by clicking Z, because this is a Z direction. Z, enter, and you can click on specify the first extension line origin. In this case it's this one or this one, and you can click on the second extension line origin and you can click on the extension. Okay, you can also add align dimension, maybe in the Y direction, so it's Y, and maybe select first line origin, second line origin, dimension, location, this one. So usually after you maybe after you create this one, you usually extend the dimension until the bottom part. So that's why after you create this dimension, you have the option to add another dimension until the bottom part. Let me show you. Align dimension, maybe the Z direction, first, second. Okay, and then you want maybe this one to this one. Sorry, this one, because it has to be aligned, so you cannot click on the imaginary point like this one and this one, and you can just adjust the alignment for all of them. And as you can see, it's already aligned. Okay. You can also maybe from the ISO view you want to copy them again, but this ISO view will be maybe rebar 1, maybe rebar foundation, maybe, and in this case it's this one, and you can click maybe on the rebar foundation to see the rebar. And so if you want to hide the rebar annotation, this is similar as last one. You can just click object show hide, and rebar annotation show or hide. You can just click on this part, enter, and click hide, H, enter. So you can see the rebar annotation is gone. You can also delete the dimension if you want. And so in this case, maybe you want to only show the C1, so that's okay. Maybe the C. So sorry, maybe the foundation. So you can just show the B part like this, or you may want to only show the upper side, maybe. So in this case, it will be P4, P5, P6. So only B1 maybe, or B1 and B3. Again, this is up to you. Yeah. So you can easily change the rebar style that you can in here, and you can determine as much as 3D view or front view that you can. Okay. So in this case, you can see that the CIM view is the drawing mode, but if you want to print the front view or 3D view, you can do so by clicking C drawing. So as you can see, all of the drawing is inserted in this area. So you can see in the model there's nothing, and you can see in this part. So this is the file that is included in the website, the CIM-defined.site. So there are a DWG that this is, of course, you can just create this in your AutoCAD file, and you can just import them just by click and drag and drop like this. So as you can see, the sheet is already inserted in this CAD view. And to assign this object to become a sheet, you can just click on sheet like this, copy, and maybe you can just name them sheet, and you can click on the select here and select all of this, enter, and specify the region. Select region from here to here. Okay, so I already have a sheet like this, as you can see. And if you want to insert some of the view to the sheet, you can just click here and drag and drop as well, like this. Similar to the other one. And 3D view. Okay. This can be mitigated by changing the ISO view to the left, so that the gap between the layout and the ISO view can be lowered. Okay. Okay, so that's all that we have time for this class. So I will see you next week to bring you FSM, so full span method creation of a bridge. Okay, thank you.